right, thanks for joining us. My name is Dusty Lang. I'm the director of the DHS SBIR program. And welcome to the Department of Homeland Security, Science and Technology, or DHS S&T, as we're also known, Deconstructing SBIR webinar series. Today's episode is on OATS RFIs. But before we begin chatting about the OATS RFIs, let me just, I know there were some folks that were new to SBIR that were signed up, so just very, very quick broad overview. SBIR, Small Business Innovation Research Program, was authorized by Congress in 1982. Three-phase program for us to partner with small businesses to meet the needs for innovative solutions to federal agencies' missions. One of the great aspects of the program is that once you have an SBIR with any of the federal agencies, another federal agency can leverage that SBIR. So if you have a phase 1 or phase 2, then we can do follow on phase 2 or phase 3. Phase 2 is a little bit more circumstantial, but always can do a phase 3 with any company that has a phase 1 or phase 2 SBIR. So DHS, having a slightly smaller budget back in 2015, said we're going to really make a goal of utilizing this capability and established what's called OATS, or Other Agency Technology Solutions. And this is where we purposefully go out and would do market research to find solutions for SBIRs that had been initiated at other agencies to determine if there was a way that we could use that within DHS. So one of the things we've done this time is kind of flip that on its head. I wanted to see how small businesses, again, you guys are the innovative ones that have come up with these technologies to pursue, how can you use ones that you've already initiated at other agencies? How can you see those technologies being used for DHS? So I've worked with some colleagues at CWMD, CISA, and the Coast Guard to come up with some topic areas for which we were seeking some information. So for the 3 that we have that we're going to be discussing today, the standoff, chemical, biological, radiological, and/or nuclear threat detection for citywide coverage, the 5G Internet of Things for situational awareness system, the autonomous vessel tracking for ports and waterways. I've invited 3 folks who have graciously agreed to come and chat about their missions and their areas. I think the important piece to understand is you develop these technologies for another agency, and those agencies' missions vary. So the way that they were intending on using them and what will be successful for them may have to be a different look for DHS. So I want to make sure we gave the opportunity for folks to be able to understand what that mission looked like for these particular applications. We are going to start with our CWMD topic. So I'm going to invite Roger Gima to join me now. And Roger, if you'd like to start us off and chat about the CWMD RFI area.
Thank you, Dusty. Good afternoon, all. As Dusty mentioned, my name is Roger Gima. I am the topic generator for this specific topic, the CWMD, the standoff CBRN threat detection for citywide coverage. Just a little background here. We've been in this business specifically on the radiation side for a long time, networking detectors, collecting that data, especially for specific deployments within the local area and around the country. And I've actually worked with groups that do it around the world. In December of 2018, DNDO, which is what we used to be, the Detection Nuclear Detection Office, we actually used to only do rad nuke. Now we do chem, bio, rad nuke, and this year we're adding the food ag vet component as well. So as our spectrum of detection challenges have grown, the abilities that we are trying to gain overall, we're trying to jump into this sphere of detection kind of quickly and not start from scratch. So we have some understanding and some background of developing technologies related to this, but in this scenario, what we're trying to do is jump further ahead and used existing technologies and available technologies that are almost there to develop ideas of ways to detect within cities, citywide, not just couple blocks, but citywide network detectors. And the idea is that from further away distances of more than just 5 to 10 feet, we're looking to go, across a lane of highway, a few lanes of highways, and detect something from a corner of a city block to the opposite corner of the city block. And with that, integrating any visual sensors as well, and incorporating those in a way so that it's meaningful when they're combined, which gives operators and emergency responders more information as to what the scenario and the threat could be. In this scenario, we have worked on the rad nuke side. We have worked closely with DARPA on the Sigma Plus side. While these things seem similar with what DHS is doing and what DARPA is doing, we are more focused on specifically trying on the city level, developing a network or looking at technologies that would enable a network of detectors to work, not just rad nuke, but also the chem bio side, other sensors, and again, implementing anything related to food ag vet if that's possible as well. So here are a few other resources that I have found on the slide. Those will be sent out to people, I think, at some point, but those are a few more resources to get some information on what has been done, what kind of scenarios could exist, understanding the threat ID tracking, and the whole arena when it comes to understanding what threats enter a certain area and having that area monitored by operators and emergency responders. I know this is a very vague topic, and there seems to be a lot of overlap within other topics that have come out of our office, but there are specific things to each topic that we are highly interested in. And in this case, it's that city portion. We're, for example, looking at the city of DC, and if there was another event that we had to be involved with, for example, some sort of the inaugurations or July 4th or that sort of situation, we want to be able to justify putting detectors in certain places and having long-term detection of those areas prior to an event, during an event, and after an event. And when I say event, I'm talking about the actual, like a July 4th event or inauguration or that sort of thing. So these are the things I'm looking at. I want to gain this information for a long period of time, not just for a short period of time. And the longer that we can collect this data, the more information we have on understanding the background, and baselining the area before having an event such as the July 4th. That's all I have to say for this topic right now. Dusty, I'll hand it over to you.
Thank you, Roger. I think that it's fantastic that you made that distinction that folks need to look at, specifically what's being asked here, because often it is easy to look at something and go, oh, well, we're doing something similar, so this should be able to apply. Make sure you're looking at specifically what's being requested in this, if you've looked at other ones, and understand the differences. And thank you for those resources. For folks not familiar, this will give them a head start on how to start finding out what the needs are. I'm now going to ask Dr. Garfield Jones if he can join us and talk to us about the 5G Internet of Things Situational Awareness Systems RFI.
Thanks, Dusty. Sure thing. So this RFI is from the Cybersecurity and Infrastructure Security Agency, which we affectionately call CISA. We're seeking, technologies on robust 5G IoT, situational awareness and situational awareness system, which is, we call it 5I SAS capability that can really enhance situational awareness of our current platform, 5G components, and of course the Internet of Things. So just a little background about CISA. CISA is the agency that basically we are the the nation's risk advisor on cybersecurity. So we look at the threat, we look at ways to protect the homeland from and federal agencies from cybersecurity threats. So as we go back into this RFI, the 5I SAS can use phone sensors to characterize normal healthy conditions, provide alerts when suspicious or healthy local environments occur, and whether they're bugs, rogue sites, jammers, RF weapons, and so on. And these mobile or cell phones can, we're kind of envisioning, I guess it's been put out there that we're looking at for secure containers running on mobile operating systems with enough memory and computational power to perform the 5I SAS functions without really impacting our normal operations or normal device functions. So another piece of this is the conversation, whenever we go with this conversation about 5I SAS, it usually involves multi-axis edge computing. And multi-axis edge computing is kind of a network architecture that brings real-time, high bandwidth, low latency access to network, and basically allowing operators to open their networks to a new ecosystem or value chain, as you could say. So as we move towards that edge, questions come up of how do we secure IoT as 5G enables much more than before? What risks or capabilities are needed locally to ensure security and privacy? How do we conduct our business, but also keep our SOC and NOC and our security operations centers, our network operations centers informed from a visibility standpoint of this view. So I mean, these are things that we're looking at CISA. And when you go with some of the issues that we run into with, especially when you're talking about this MEC or this multi-axis edge computing, you've got the real estate issue, which is basically the closer the user edge computing gets, the more complicated it gets, because it's got all these devices that you have to worry about. Power is one of the things that you really need to worry about. Building out data centers with dual power feeds. That's going to help resilience. The physical environment, pushing compute resources to central offices or customer premises may mean we have to retrofit environments and or operating in less than ideal spaces. And I think also you have to look at the fiber and network co-location issue, where sending network data over an out of the way route in order to get data there sooner or have it cost less. So you can have trade-offs like that. But this is some of the things that we're really looking at, and some of the areas. And I think the last part of it is the operations. We really don't want to impact operations. We want it smaller and faster, so it does not impact operations. Finally, I'd like to say, if enough of these devices are issued, then they could not only detect unhealthy and insecure situations, but they can also triangulate the physical locations of suspicious IoT and 5G devices or jammers or weapons. So I think you really have to, we're really looking at that and kind of hoping to get some folks involved in this. That's all I have. Thanks, Dusty.
Thank you, and thank your fuzzy folks for participating as well. It's amazing how the post office knows exactly when to deliver it. Mine are tucked away. Hopefully you can't hear them, but they've been trying to participate as well.
He was tucked away in the basement. It just never.
He's like, no, you're not keeping me from this. This is my big moment. Thank you very much. I appreciate that. And I think folks will have seen, speaking of which, my mail is getting delivered right now. So I think folks will have seen that in the chat, we did post the links that were on Roger's slide for references. So make sure you're copying those down. And then we did the same for the ones that Gary presented to us just now. You know, and obviously we're trying to do that so you can copy and paste and are still able to pay attention. So don't visit those now, wait until the end of the webinar. And now we have our final topic. I want to introduce Dr. David Wiesenheim for the Autonomous Vessel Tracking Ports and Waterway, RFI. Thank you very much. And if you want to chat with us about that, that'd be great.
Hey, great. Good afternoon, good morning to everyone. Very happy to be here, very happy and excited about this opportunity. My name is David Wiesenhahn. I work in the Coast Guard Office of Research Development, Test and Evaluation, at headquarters in DC. Within the RDT&E enterprise of the Coast Guard, there are 6 domains, and I am the domain lead for modeling and simulation. We have a few other domains for surface and air and networks, but I do modeling and simulation. So the M&S domain, a little background, includes sort of traditional things like operations research and developing modeling and simulation capabilities that can support users within the Coast Guard, help them with the 11 Coast Guard missions that we have to do some of the traditional analyses, but also more and more willingly getting pulled into areas such as artificial intelligence, machine learning, data analytics, and video analytics. And I'm actually very excited about this direction. I think it's a good direction to go to capitalize on some of the advances being made in industry. And so I think it's a good direction for us to go. Recently, the M&S domain's been looking at video analytics, different things to do with that. There's different ways that it can be applied, and we're trying to figure out some of the best ways we can apply it, what makes sense, what can be done operationally. We are an operational unit. And so we always have to keep in mind of how do we employ something, build something, develop it, and then employ it operationally, whether it's on an airplane, whether it's on a small boat, whether it's on a buoy or what have you. And so that's one of the things that struck me about the Coast Guard mission. There's a pretty diverse set of environmental and applications. We do have flying assets with gimbals filled with EOIR sensors. We have man boats. We're also looking at autonomous vehicles pretty heavily. We're also looking at autonomous drones, UAVs to do some of this. We also have assets that are closer into ports, such as buoy, navigation aids, and regular port infrastructure. The Coast Guard works very closely with other partners at ports and other facilities. So there's a lot of opportunity in this area to apply some of these recent technologies in a smart way. And one of the areas that the Coast Guard is very interested in is what we call maritime domain awareness. It's just like the word sounds, you know, how do we maintain awareness of the maritime domain? And when you think about it, there's a lot of coastline, a lot of harbors, a lot of ports, a lot of rivers, waterways that we want to keep track of and monitor. And it's probably impractical to even on one port. If you just take one port, it's pretty much impractical to have a single watch stander there watching camera feeds, whether it's a full motion video or IR feeds. It's pretty impractical to have somebody watching that 24/7. And you can imagine all of the different sensors that you could easily put into a port. And so again, we want to apply some sort of smart technology to lighten their load and even do a better job. Humans are good at some things and computers are good at some things. And there's a very good synergy between these two that we want to capitalize on. And as I mentioned earlier, what I really like about this project is working with DHS. The Coast Guard, we don't work alone. We work closely with law enforcement. We work closely with TSA, with DHS, of course, with CBP. And so all this information that we can gather, again, a single person or even a single small squad of folks at a single port, we can overwhelm them with information. And so, and even once we distill the information and get actual intelligence out of it, we have to make sure that we feed it smartly to the rest of the team and the rest of our national infrastructure. So my thought with this project, I have a background in developing infrared sensors, and I think this is a good opportunity for an unmanned or autonomous sensor that we can mount on a buoy or a navigation aid. So if you imagine a port or waterway or channel, if we were to mount an EOIR sensor on that, and it can be there passively as vessels transit in and out of the waterway. And to be honest, it doesn't have to be an EOIR sensor. There's certainly other options out there. But sort of the baseline approach is an EOIR sensor. As a vessel's transit in and out, it could record the vessels. And the concept is that would have something like a license plate reader, where it could read the vessel registration numbers that you see on the side of small boats. And ideally, it could also look at the color of the registration stickers. It's like your cars in some states. The registration stickers have a color denoting which year you registered in, and it's easy to look at it and easily see whether it's expired or not, whether it has to be updated. And so that's another feature that the system could have, is to be able to detect the color of the registration sticker. But the baseline configuration is that it records the transits of the vessels coming in and out of a harbor. And it records some basic features of it: the direction, time of day, the size, maybe the speed of the vessel, registration number. Larger ships, typically they'll have the name of the ship on the bow or the stern, if it can read that and recognize that. And that's all stored in a database. And there's different ways that could go. Once we get the system sort of up and running, there could be a pre-programmed alerts to look for a certain vessel that you're interested in. It could be archived for later forensics. Did this boat transit at unusual times? Was there suspicious activity? And we could apply even more, another layer of artificial intelligence algorithms to that. And once this gets networked with the larger national law enforcement, there's a wealth of possibilities on how this could be exploited. So I think this concept it has a lot of potential to provide a very much needed capability. It would reduce the workload or improve the quality, and really make a solid contribution to our port security. I think the other details are in the RFI on this. And I think that's all I have to say.
Thank you very much. So I have a couple items to go over, some final thoughts, but I wanted to thank the panel here for joining us, for providing more information, and for helping me to pursue some RFIs on notes and be able to see what we can do to use SBIRs from other agencies. So thank you, three gentlemen, very much. And we hopefully will be getting you some ideas soon. As far as the folks listening, the due date for submissions to the RFI is July 30th, at 11:59 p.m. Eastern time. So at that point, we'll be looking at all the submissions we received. And this is an RFI. This is not a procurement. So bear in mind as you're putting in your submission, we've had a couple of folks ask some questions. The best types of questions to ask are the ones that help you understand the boundaries and the parameters of what we're trying to achieve. So asking the number of sensors that we're going to buy, this is not a procurement, this is an RFI. So we're looking to see what the art of the possible is. So if, for instance, you have an idea for something and you're like, hey, I could do this, but you know what, it involves us, potentially violating privacy laws, then make sure you ask us those types of questions. Make sure you're asking us the ones that would eliminate whether your potential technology solution is even viable in this scenario. Those are the best types of questions to ask. And if you send one that is one that we're looking at and going, hey, you have to tell us what this is, we'll come back to you with that, but that's the guidance there. So where do you submit those questions? If you have questions, you can submit them to Danette Williams at hq.dhs.gov. She is also listed in the RFIs, so she's at contracts. She's in our Office of Procurement Operations, or OPO, as Mr. Jones or Dr. Jones said, lovingly call. And I'm glad you had to say what CISA stands for, because I always get tongue-tied. The other option is to send the questions to stsbir.program@hq.dhs.gov. That is my office. And if we receive them, then we'll do what we can to get questions answered to folks so that we can get the best possible solutions. And of course, we have our website. They're available. These are not going through the portal. So if you've done work with the DHS SBIR program in the past, this is not going to go into the portal. This is going to be submitted to the email address in the RFIs listed. So make sure you're paying attention to that. If you have any questions about the RFIs before July 30th at 11:58, make sure you contact us. If it's about the eligibility and those sorts of things, you can certainly contact us and we can help clarify anything that has come up. So unfortunately, we knew we were going to be structured today. This is a short webinar that we would not be able to have time to take questions, but we are prepared for them. You just have to get them to us another way. So I'm going to, with that, say thank you again, gentlemen, and we're going to bid everybody goodbye and wait eagerly for submissions. Have a great National SBIR Week.